For example, 10 volt power supply plus minus. The plus voltage given to the transistor collector to resistor R2 and one LED. Whenever power is there, the LED will glow. Right? So that means I am applying 10 volts. Then the resistor limits the current. The current flowing to collector is called IC or called as collector current. The collector current, note down the formula IC equal to beta times IB, where beta is called a current gain. Note down. Current gain of the transistor. For a given transistor is decided by the manufacturer. While buying a transistor, you should ask what is beta. Beta can vary from 10 to 1 lakh also. 10 into 10 power, even more than that also. When this is a beta is very high, it is called a super beta transistor. They call it as a nickname is super beta transistor. Normally it can vary 10, 100, 200, 500, 1000, 10,000, 15,000. There are more than 40,000 transistor manufactured. There you can go and buy data book for transistor. There are maybe around 20 to 30, even 40,000 transistors of different capacity are available. So each one will have different gain. Correct? When we talk about transistor amplifier, we'll see that transistor has 5 important parameters. One of the important parameters is beta. Beta, now the transistor called as an amplifier. Why it is called as amplifier? We can see that if I apply a voltage, base voltage, for example, some voltage VB equal to say 1 volt. I say that there will be a current going here, IB. Okay, that is called base current. VB is base voltage, IB is base current. That base current, when it enters, automatically, this is relationship. Base current is called input, collector current is output of the transistor. Beta is gain. Okay, so if, for example, the beta equal to 100 for this is a transistor for a BC 107. I'm giving there are 20,000 transistors. I said one transistor. I don't know the exact number for understanding purpose. Equal to 100. Correct? I say my IB supplied to base is, for example, 100 microamps. What is my IC? 100 into 100 is nothing but 10,000 microamps, or I can say that 10 milliamps. The current is amplified 100 times. That's why the transistor is called as an amplifier. Okay. What way it is useful for NDR? Correct? We know that this voltage, I told you, this I call the LDR resistance. I call this as R2. Okay. RLDR. I call RLDR. This is R1. The voltage at this point, I say that VB equal to the supply voltage. What is voltage I am giving here? 10 volts. Note down. This is I given 10 volts. Same voltage is applied to through the resistor to collector. This is my emitter terminal. This is base terminal. Same voltage apply. So the voltage at this point is nothing but R1 divided by RLDR plus R1. Okay. Whole thing multiplied by I call VCC supply voltage. Multiplied VCC is VB. This voltage. This voltage is applied here. This voltage is applied. So now if you apply this, the current going to the IB. What is IB? Current going to this. That depends upon VB divided by RLDR. This voltage you can compute using this formula. The current going is IB equal to this voltage VB divided by this resistance LDR. That current only is going here. Okay. Now that current is known. That will be multiplied by beta times. Here IC is flowing. IC equal to beta times IB. Okay. Now if light is varying, what will happen? In this case, the IB equal to, I said, VB divided by RLDR. Correct? The LDR values vary depending on light intensity. So the IC output current will vary if light intensity varies. 0 to 100 lumen, if you vary light, automatically IB going into base will vary. Automatically IC will vary. IC equal beta time. So this is how you can measure the change in resistance LDR, which is proportional light intensity. So I can use LDR as a light meter. Correct? Already calibrated. If I vary the distance 0 to 100 lumens, my output voltage the IC will vary. So for example, 0 to 100 milliamps something. Correct. So if the 50 milliamps current is going, I know that the light falling on this LDR is 50 lumens. If the current is 30 milliamps, I know that lumens light falling on my LDR is 30 lumens. So I can use my LDR as a light sensor. Similar to this one. Okay. So this how you can use it. Another thing is, for example, instead of sending a constant light, correct? A fixed light, say I said 50 lumens. Instead of that, I can this LDR photon, all this thing can be used for measuring the light intensity. Other example is making them to as a electronic counter. For example, in a conveyor belt, there's a conveyor belt. Okay, and conveyor belt is rotating two rollers like this. Okay, on which objects are coming. And this one, there are objects moving. For example, in your factory, items are moving from like this direction, because this is rotating like this conveyor belt. Now, I wanted to count number of objects moving. What I can do is, I can put one light source here, a bulb or something. Okay, it emits lights. Other side, this side, I put my phototransistor. For example, here I put the phototransistor or LDR. Okay, then if whenever light hit, when there's no object, what will happen? Light will come and hit. Correct? Then there will be output voltage proportional. If the object comes, what will happen? Light will not hit my sensor, because this light is there. The objects obstruct the light. Then what will happen? You will get a pulse. The pulse here will be like this. For example, you give 5 volts for this one, I'll get a 5-volt pulses like this. Each pulse represents one object move. So I can use count objects. For example, you in the factory, correct? Packaging. You are doing how many items are get packaged, how many of this order. I can use this. I can use LDR, or I can use photodiode. Yesterday, we talked photodiode also, you can use it. Or I can use phototransistor itself. Correct? This here, I can use this side. I have my light source. Light is emitting. Here, conveyor belt is there. Objects are moving. Correct? I say that these objects are moving. Object moving. So light is one. I'll get light pulses. Here, I will get the pulses. So if I count number of pulses, I give this equal to 5 volts. I'll get 5 volts. Each pulse represents one object crossing the sensor. So this is called light-based counter. It can be humans, it can be objects. Whenever light is obstructed, you get pulses. This is the application of phototransistor and also photodiode. Correct? Again, I can put a light source here. There's a conveyor belt, objects are moving. So whenever this, it will generate a pulse. Any doubt in this?
No doubt, sir.
Okay, fine. Thank you. So then next thing is, I will come back to range sensor. Next type of sensor widely used is distance measurement, which is called a range measurement. No doubt, correct? In autonomous vehicle, there's a vehicle in front of you, correct? Yeah, object in front of you. Some pedestrian is crossing. You want to find the distance between you and the pedestrian so that you can apply brake or decelerate, whatever you want to take decision. In the case, you need to find the distance between you and the object in front of you. So you can use 3 types of sensor. One is radar, other one is called lidar, then third one is called infrared sensor, IR sensor, range sensor. If the sensor is used for measuring distance, it is called a range sensor. This is the terminal used in industry. Okay, so I am using infrared based sensor. Please see that this is the IR sensor. This is called as active sensor, no doubt. Already we talked about active sensor when we which illuminates the object, and the reflector light energy is measured based on the detects objects or distance. So the IR sensor based this one, I have IR diode. This is my IR diode, light source. I give voltage, correct? Pulses, for example. Then it emits light pulses. The light pulses travels in front of, because this is put on my vehicle. For example, this is my vehicle on which this is there, it emits. So the light goes and hits the object. This is the object needs to be detected, a rectangular object. It hits it and some light is reflected back. The reflected light will be captured by the detector. This range sensor have 2 things. One is called transmitter, Other one is called receiver. So yeah, IR light pulse is created. This is the IR LED. IR LED, when I give pulsed voltage, it generates light pulse, IR pulses. This is called as transmitter. It generates the pulse, light pulses. Okay. Now, it, for example, it emits one light pulse. Let me clear it. Maybe at t equal to 0, this is time axis. At t equal to 0, yeah, light pulse is emitted. The duration of light pulse is generally microseconds. What type of light? IR, infrared light generated by this diode, that is IR diode. For that, I am giving a pulsed voltage. Okay, I gave one pulse. Now, this light travels from here and hits this object. This is object to be the rectangle, this one, and it is get reflected. Okay, and the light travels back. The received light will be captured by another phototransistor. Correct? This can be a phototransistor, which is sensitive to IR light. So immediately what it generates, it will generate a pulse. What it generates? It generates one more pulse, but the pulse will appear after some time because you transmitted pulse come this. No, this is time t equals 0. I transmitted. The light pulse came after t. This is 10 microseconds, for example. Or for example, this is 10 micro too much. Let me say 10 nanoseconds. I will tell you why it is. Okay. After 10 nanoseconds, that means the time difference between these two is called 10 nanosecond. 10 into 10 power minus 9 seconds. It receives. Now, this time is the difference in this. So what is the difference? I call this a T1. This the pulse when it returns called T2. T2 minus T1 is called as capital T, which is called time of flight. Note down. It is called time of flight. What is flying? The light pulse traveled from this, traveled to the object, hit the pulse, reflected back and captured. So the light pulse travel. So light pulse has traveled. That is called flight time. Divided by 2. Correct? That means time taken for light pulse from the transmitter to object is half of the time because the same distance equal. Multiplied by C. If I do that, I can find what is the distance between two objects, between the sensor and the object. So the distance d equal to speed of light c multiplied by the time, total time, capital T, whole thing divided by 2. That is the formula. Using this, I can find the distance between the object in front of you using IR sensor. So IR sensor can be used as a range sensor. Okay. What is this figure is showing? The IR sensor, how much distance I can measure? Distance between these two. Correct? Generally in the order of centimeter to few meters. IR sensor, you know that in your car, when you are doing backing, correct? Reversing. That time you are getting beeps or no, you will have camera. Also, there will be a sensor you would have seen in backs. This one, you will have some 3 or 4. These sensors are nothing but it can be ultrasonic sensor. Next I am going to show, or it can be IR sensor. So it sends light beam. The distance between your vehicle back and the wall when you want to park can be few meters, maybe 1 meter, 2 meter, nothing. But so the light, the voltage received by reflected light varies from distance. If it is closer, more voltage. If the vehicle is far away, less voltage. So the input output calculation range means distance between the IR sensor and the object to be detected. In this case, wall, parking, or a vehicle behind you when you want to do. So this is how it works. Okay. Next thing is, so this you can see that the infrared sensor can maximum work for few meters, 0 to maybe 400 centimeter, 4 meters, something like that, not more than that. Generally, few meters only. If I want to measure longer distance, I can use laser-based sensor, range sensor. This is what LiDAR. When we talk about autonomous vehicle, we'll talk about that. Already, the 2023 where they've done the code, they will be knowing about LiDAR. But simplest sensor is, I have a laser source. Correct? This is my laser source. It transmits a laser pulse. Correct? The pulse travels and hit the reflector or object, target, and it is reflected with dotted line. And there's a receiving sensor. This is my laser source. that also pulsed source. That means it is going to send on a small laser pulse, a duration of, for example, 100 microseconds only the width of the light pulse. Laser pulse. It goes there and hits the object, that is red color, and the solid line returns. There's a phototransistor. Phototransistor get a pulse. Okay. So then again, same as what is IR sensor. So I am transmitting one pulse and reflected pulse I show in another color. This is the reflected pulse after some time. The time difference between is, I say that 15 nanoseconds. Okay. 15 nanoseconds, that is time divided by 2 multiplied by 3 into 10 power 8. So that is the distance between these two. Correct? This is 50 into 10 power minus 9. I said 50 nanosecond. So that is 25 into 10 power minus 9 multiplied by 3 into 10 power 8. 10 power 8, 10 power gone, this become 10 power minus 1. 25 into 10 power minus 1 multiplied by 3. Nothing but 75 into 10 power minus 1. What is that? D equal to, I can say that 0.75 meter. The distance between this laser based rangefinder and the object is, if the time is 50 nanoseconds, total time capital T, it will be 0.75 meter. So again, this also work at time of flight, same thing. Correct? Laser light or infrared or regular light, or you can use radar also, it is same. Okay, so this is how it works. So any doubt in this? Transmitter transmits, hits the target, reflected, sensed by the sensor. Correct? This is so, this is sensor. I can give it. Okay, shall I go to next sensor? Okay, next
Yes,
one
sir.
is, yeah, next one is ultrasonic range sensor. Third type. Because why I'm talking range sensor, in autonomous vehicle, we need this. Okay, measuring distance between your vehicle in front, back, side, all this thing will be long range, short range, parking. Parking will use ultrasound or infrared. When going in the lane changing, you have to see whether vehicle nearby is there. Next lane, between two vehicles, maybe 4 to 5 feet, or only between two vehicles in the lane, between two lanes. So you can use ultrasound or infrared. But if you want to measure long distance, you can use laser or lidar or infrared. So in case ultrasounding also, again, you have in alpha, this one, you need two. One is called transmitter. This is transmitter, this is receiver, RX. So this emit sound pulses. Please note that sonic means sound in Greek, correct? Ultrasonic means high frequency sound. Above 20 kilohertz is called as ultrasonic sound range. Correct? Ultrasonic also uses time of flight technique, similar to what we saw laser or IR sensor. This fellow transmit a sound pulse. Correct? A sound pulse is transmitted. If there's a target, an object, it gets reflected, it is pushed back. This is the reflected sound. Sound pulse. And this is a transmitted sound pulse. Who creates sound pulse? One transmit ultrasonic, this one crystal, ultrasonic crystal. If you supply a voltage pulse, right? I have ultrasonic crystal. If I supply a voltage pulse, there is plus minus. If I supply, the crystal will generate sound pulse. Right? This ultrasonic. So sound pulse will travel. So that pulse is represented. Now it is traveling. Again, it goes and hits and come back. This is a reflected pulse. This is transmitted. The time difference this do is called capital T. Okay. Capital T divided by 2. Only thing is, please see here, the formula is different. Distance D equal to speed of sound is 330 meter per second in sea level. Light is C equal to 3 into 10 power 8 meter. Please the light speed. Here it is just 330 meter only per second. That's how sound will travel at sea level. Multiplied by T by 2 is the D. So I can use this. Generally, the ultrasound frequency can send a burst of frequency like this. Instead of sending a single pulse like sound wave, it's in a high frequency. Generally, there are 40 kilohertz. 20 to 40 kilohertz the sound vehicle. Because if sound is sent in the audible range, everybody get irritated. Whenever the vehicle comes, you will hear the sound. That's why the ultrasonic sensor uses 20 to 40 kilohertz is the frequency of the sound signal is sending and receiving. So that's how it works. Okay, so this sensor calculate the time to same as that, correct? Capital T divided by 2 multiplied by 330 if it is sound level. For example, if you are Ooty, correct? It is not at sea level. It is around 3000 meter, correct? So the speed will reduce. Maybe it may become 280. I don't know exact number. It may become 200 or 250 meter per second. Higher the altitude, the air density reduces, automatic sound speed reduces. At the sea level only it is 330 meter. That you have to remember. Correct? So if a vehicle you are driving at a higher altitude, the sensor speed changes. Okay, that you have to take care. But light speed doesn't change. Whether you are in the earth surface above 100 kilometer or above Himalaya, go to outer space or universe, anywhere, the speed of light is constant. That is the advantage. Ultrasound sensor, you have to know at what height you are measuring, that you have to be taken care. Okay, next sensor is what you call thermoelectric sensor. We saw 6 type of change in resistance, change in capacitance, change in inductance. Piezoelectric already explained, used for measuring in-cylinder pressure measurement or pressure transducer using. Then now we previously we saw light-based sensors or photoelectric sensor. The last one is thermoelectric sensor. Thermoelectric nothing but thermocouples. Already we know. Thermocouple is made of two dissimilar materials. So A is one material. This is B. So I forgot. So I take two different materials. I will show in next slide. There are two different. For example, this is copper. This is also copper. You take two copper piece wire and I connected with another wire constantine. Constantine another material. Okay. So this wire is made of constantine. These two pieces which I represent B is called copper wires, and by connecting or melting, correct, I have to make a junction by fusing the constantine wire one end with copper one end. I form this junction. I call J2. Similarly, the constant other end with another small piece of copper wire, I fused, I melted, I made a junction. This I call J1. Correct? So okay, J1. Now there are two junctions are there, and one junction J1 is exposed to temperature T1. For example, this is 10 degrees centigrade, and the other junction is T2 is, for example, 50 degrees centigrade. It is exposed. That means both there are two junctions formed by two dissimilar metals. Two dissimilar metal wire fused to form junction. Correct? That produces EMF is called as thermocouple. That means constant wire connected to copper wire, two pieces, and this one. Now the volt, it generates a voltage where here the voltage generated is this one. So that voltage is proportional to, correct, is equal to alpha multiplied by T1 minus T2. Correct. The temperature difference between two junctions J1 and J2 multiplied by alpha. What is alpha? Alpha is called a Seebeck coefficient. Note down. The voltage generated by thermocouple is proportional to alpha multiplied by the temperature difference between two junctions. One out of that, one junction sometimes they call it as cold junction. Correct? Cold junction is supposed to be maintained at 0 degree centigrade. If I want to measure temperature with respect to 0 degree, one junction will be put at this one 0 degree. How? I insert the junction to a ice. Ice, you know, the temperature 0 degree centigrade. Other one is where I want to measure the temperature. T2 junction is subjected to wherever I want to measure the temperature. So automatically the T1 is going to be 0 degree and T2 is the temperature, okay, which I am measuring temperature. So the difference is equal to delta T. Delta T multiplied by alpha is called Seebeck coefficient. The Seebeck coefficient depends upon what wire material, whether I am using copper and constantine. Correct? There are thermocouple pair. Next slide I am going to do. Depending upon the this one varies, Seebeck coefficient varies. Okay. So accordingly, if you know that, I can calculate what is temperature. EMF pro is proportional to, see, one temperature maintaining. This is called a cold junction temperature, reference junction. I am always maintaining using ice cube. Correct? I inside ice, I inserted this junction. So this is 0 degree. That become reference. With respect to the other junction has a higher temperature. So from that, if I multiply coefficient, I get the EMF. EMF may vary from 0 to 100 millivolts when temperature varies from, for example, 0 to 1000 degree. The T2 temperature varies from 0 to 1000 degree. Then my thermocouple will generate 0 to 100 millivolts voltage. This is how it works. Any questions? Okay, I said there are different type of thermocouples. Basically, these are well-known couple, correct? Particular common thermocouple, you need two dissimilar. One is, I said A material, other one, these two pieces of B material, same material. I said this is Cu, this also Cu. This is, I said, concentrate. Like, so there are two junctions, two dissimilar wire forming, that is what forms the thermocouple. Okay, now you can see here, B type thermocouple, somebody says, that means one wire is made of platinum with 30% rhodium. Other wire is made of platinum with 6% rhodium. Please note that it is a platinum wire, one with 30% rhodium, other one is 6% rhodium. That because there are two dissimilar materials. Together, if you form a junction and the generated thermocouple, it can measure temperature from. I think there is a small mistake. Cannot be this number, there's a mistake. I took it from internet. There may be some small mistake. Okay, this can be 0 degree. This is a small mistake, typo mistake. This is 32. No doubt. You know the 0 degree centigrade equal to 30 degree Fahrenheit. Many times the thermocouple can measure minus temperature. Yeah, minus 150 degree to plus 1200 degree also. Correct. So if you want to measure 0 to 1700 degree, it can measure. Okay. Fahrenheit it becomes
So then it will be 3100. Okay?
What?
The range in Fahrenheit will be 32 degree Fahrenheit to 3100 Fahrenheit. That would be okay.
Yeah.
Okay.
So in centigrade, 0 to 1700. Which one? Platinum, 30% rhodium, one wire, other wire. They call B-type thermocouple. If somebody says B-type thermocouple, definitely it is made of platinum wire with 30% rhodium, one wire, other wire platinum 6%. If I say E-type thermocouple, one wire is nickel chrome. Please that this is alloy, nickel plus chromium, and other one is constant. Correct? So it can measure from 0 degree centigrade to 0 to 870 or 32 to 1. I think there are some, there are some which can measure also negative also. So like that, J type, K type, iron constant J type, the range is 0 to 760 or this one. Similarly, K type is nickel chromium, one wire, other wire is nickel aluminum alloy. This is iron, one wire, constant and other wire, two wires. There are nicrosil and nisil. This is a special material which can measure up to 1000, 0 to 1000. Similarly, you can see the different combination. Last one is called a T type. One wire is copper, other one is constant. That's what I'm talking, right? Copper constant. Okay, so it can measure minus 75 degree Fahrenheit to plus 700 Fahrenheit or minus 59 degrees centigrade to plus 370. So if I want to measure temperature up to 400, for example, I can use only T type. I cannot use this more than this. It will not work. If I want to measure from higher temperature, I think here also some mistakes are there. Sorry, I did not notice. Yesterday, I took this one from internet, one site. I did not notice. Okay, there are small minor mistake, but you can say that it is 0 2. The minus is okay.
Okay, sir. Understood.
Okay. So right one you can see in the net. Okay. So this is this is how the thermocouple works. This is based on Seebeck effect, which is called a thermoelectric effect sensor. This is last stage. Then if I connect multiple thermocouples, for example, this is one thermocouple, this is another thermocouple. You can see that multiple thermocouple, if I connect in series, it can generate high voltage. For example, one thermocouple, one junction, correct? Cu and constant. Correct? One junction is formed. One is plus other. So if I temperature is 0 to 1000, I said 400 degree or 700 degree. If I vary, it may measure 0 to 400, say 40 millivolts. Now I am connecting in series. Correct? First thermo T1, this is T2, this is connected in series connection. Now finally, if you measure, how many are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 junctions are this is T2, this is T3 junction, or I say J1, J2, I can say that J1, J2, J3, this is J10. 10 are connected in series. Each thermocouple generates 40 millivolts when temperature is 400 degree. So what is total voltage? 40 into 10, 400 millivolts it can generate. So I can use the thermocouple to generate voltage. That is called as thermopile. Correct? Temperature, what it does, it converts the heat energy into electrical voltage. Please note that one thermocouple also generates voltage only, but voltage very small. So it can use only as a sensor. But in case of this, what I can do, if I connect multiple thermocouple, even to 100 packed together, they can generate up to 4 to 5 volt to drive. For example, when you go to outer space, you want to drive some electronic circuit, need power, correct? What you can do is, you can have thermocouple, 100 thermocouple connected in series, and they all exposed to sunlight. Sunlight is very high, correct? In the outer space, it is to 400 degree, 300 degree temperature. So that means it can generate a lot of power. So it can, thermopile can be used as a electrical source, like a battery. Thermopile can, but only thing is sunlight is needed, heat is needed, correct? Heat is needed. Then you can generate the power voltage. That is called thermopile. This is used for driving some circuits. Okay. Now that we saw different type of this one, starting from resistive type, strain gauge, used for force measurement, torque measurement, this one. Then we saw the capacitive type. Then we saw inductive type, inductive speed sensor, also LVDT we saw. Then we saw now thermocouple, correct? Then before that we saw the piezoelectric. Did I explain piezoelectric already? I think when classification is explained, if I'm correct.
Yes, sir. You talked about it being a bidirectional sensor.
Okay. Let me, before going, I will complete that. For example, piezoelectric means I take a piezoelectric crystal. Piezoelectric crystals are available naturally as a raw, this one, and then you shape it like this. For example, this is a piezoelectric crystal. You made it as a cube. Correct? This is cube. Cube means 6 faces are there. I said this is the top face is face F1. The bottom, correct? The bottom one is F2. The side face, this is I call F3. Front face, I call F4. This face, I call as F5. And opposite side, this one is called F6. Right? There are 6 faces. Now, what I'm keeping this, I'm applying a force between these 2 faces. Force I'm applying. Correct? So, for example, each side is, for example, 10 mm. Height 10 mm, width 10 mm. It is cuboid. Correct? This also is 10 mm. Okay? This is made of piezoelectric material. Please know the piezoelectricity is naturally available. You can also grow. Okay? The crystal is available. What I'm doing, I am applying a force between top surface. F1 and F2 between, I am applying a mechanical force. I say that F equal to, say, initially 0 force. When 0 force, then before applying force, what this is top and bottom, I'm going to apply force between the face F3, correct? This is the F3 phase and this is F4 phases. These 2 phases, I connect a wire. I put a metal, say a copper plate, correct? Which is touching this area, completely a copper plate, the side, correct? From this, I attach a wire, 2 wires. Okay. Now, if you apply a force of, now it is 0 Newton force. Okay. Then I apply force equal to 1 Newton between these 2, top and bottom. What will happen when I apply? There's a, due to this pressure, the crystalline structure of piezo crystal is getting deformed. Crystalline structure gets deformed. That depends upon what is force applying. Then I say F equal to 2 Newton, F equal to 3 Newton, like that I am applying. As I increase this one, the crystal different, then the piezoelectric crystal emits electrons. Please note that when I apply a force between 2 surfaces, top and bottom surface, between this, I apply a force, then the crystalline structure of the piezoelectric crystal deforms and it emits electrons. The electrons, where it comes, I will be in this surface. 1 minute. Yeah, I may use different color so that you can see it. Yeah, so it emits electron. Electron is negatively charged, correct? So the electrons will be collected one surface. So other surface, nothing will be collected. So with respect to this, you are connected two metal plates. So here there will be a charge between these two plates. There will be a charge Q. Q is proportional to F. Okay, I said Q is proportional. For example, force versus the charge Q coming out of these two surfaces, which is 90 degree, correct? But between these where the metal plates, Q is the output. Q is the output. For example, zero charge. Q charge is generally in coulombs. Unit is coulombs. Okay, generally they generate picocoulomb. I said 10 mm by 10 mm. This crystal, if you apply force, the charge generated per Newton force will be maybe 10 picocoulombs. What is picocoulomb? PC, they say, is nothing but 10 power minus 12 coulombs. Very small quantity. That's okay. Correct? So now, if I apply 1 Newton, it may generate 10 picocoulomb. If I apply 2, it may give 20. If I apply 3, 30. Like 10 Newton, it may give 100 picocoulomb. Okay. So now I took a crystal, piezoelectric crystal, having 10 mm by 10 mm cuboid, and I am applying a force on it from 0 to 10 Newton. It produces a charge. This is called a Q is called a charge output. The piezoelectric crystal generates charge. The charge is collected between these two faces. Which faces? Exactly 90 degree opposite to the force. Force is applied by top and bottom. So now this sensor is called as a force sensor. Piezoelectric crystal can be, instead of this one, I can apply pressure also. Correct? I can apply pressure, force or pressure. So if I apply 1 bar pressure, P equal to 0 bar, 1 bar, 2 bar, 3 bar, 10 bar, I apply 10 picocoulombs. So I can measure force or pressure using piezoelectric crystal. So now the charge is proportional to this. Once I calibrate, now I am applying an unknown force. I am applying an unknown force. For example, when I apply unknown force, then I am getting say 45 coulombs. Sorry, 45 picocoulombs. What is the pressure or force? We know that it is 4.5 Newton meter or 4.5 bar. This is how the piezoelectric crystal works. Where it is used? Mainly in IC engine. You know the in-cylinder pressure measurement? In-cylinder pressure measurement. What do? You have your cylinder. Inside that piston is moving up and down. And this is the cylinder head. Here you have the inlet valve, inlet port, correct? IP. This is outlet port, output port. Then you have your valve mechanism. If the fourth stroke, this one. Okay. Then you want to measure this pressure, in-cylinder pressure. How the in-cylinder pressure will vary? It varies like this generally. We know that the four-stroke engine, the x-axis 0 to 720 degree crank angle. We say crankshaft angle or crank angle we say. And the pressure increases something like this. Okay. So four-stroke engine, this is the suction stroke. This is the power. What is that? Compression stroke. CT. This is power stroke. PT. Correct? The last stroke is exhaust stroke. Correct? During piston, top to bottom coming, suction stroke. TDC to BDC. During that, a vacuum is created. You can see that the pressure is 0 bar to, for example, peak pressure goes to 70 bars, 70 or 100 bar, depending on engine. Correct? It varies. So when suction is happening, you can see that the pressure is below this one. There's a vacuum, 0.7, 0.5, something. Correct? Less than vacuum is created. So because of that, air will be sucked in. Then the piston comes to down. 100 cc engine means 100 cc air is sucked in. Then inlet valve closes. Then during compression stroke, piston goes up. Already we know piston start moving from here like this. It start moving. It comes to TDC. That time it is compressor. 10:1 compression ratio petrol engine. Correct? That is here, somewhere here. Sorry, it is somewhere here. That during the time I'm giving a spark. When I give this spark, the fuel burns, the peak pressure increases. That is at TDC. Then power stroke, piston is coming down, the pressure is dropping because piston volume increases. During this is exhaust stroke. So to measure the in-cylinder pressure, we use piezoelectric crystals. Okay, one of the application I'm trying. Wherever you want to measure pressure, you can use piezoelectric crystal. This is piezoelectric effect. The charge is produced called as piezoelectric effect. For that, piezo crystal you have to use. That is a special type of crystal. Any doubt?
No doubt, sir. Everything is okay.
Okay. Now that we saw different type of sensor, correct? And next I want to talk about the amplifiers. Okay. Before starting, I quickly go to something. The sensors, most widely used sensor in engines vehicle is what you call an angle sensor. Correct? Steering angle sensor. Correct? And wherever rotational force is happening, you want to measure. So you need a angle sensor. So to measure any rotating angle, you can use potentiometer, or else you can use optical encoder. There are two types of optical, one is the absolute encoder, other one is the incremental. Third type is a capacitive type sensor. Fourth one is synchronous. I'm not going to discuss this. Already we discussed about this when you talk about capacitive sensor, correct? So this also I'm not going to discuss. These two sensors, TPS sensor, throttle position sensor, is measured throttle angle when you press the throttle shaft. Okay, so that is one. Other one after we'll see one by one quickly. TPS sensor is nothing but a potentiometer variable sensor, correct? So if I open your TPS sensor, you will see a carbon track. You can see that this is the blue one is called carbon track. Yeah, non-conducting material. This is non-conducting material generally made of bakelite, on which they deposit the carbon track. They take carbon powder, they ground it in paste and add glue and coat it like this track, having some width and having some thickness. It has some length, this much track. So the carbon is a resistive material. So if I measure a ohm meter between this, for example, the track may have 1000 ohms between these two ends. So it is a carbon track resistor. That is what represented here. So this is one end. I say end one. This is end. This is second end. These two are called a fixed ends. Then I have, this is a moving contact. You can see that there are tongue-like structure. There are three things are coming and they will come and make contact with this. So this is made of metal, generally copper coated with nickel or something, so that it won't worn out. So this is connected to the shaft. Correct? TPS sensor has the shaft. The shaft is connected to your the throttle, correct, lever. Correct. Oh, when throttle is pressed, the rotation angle is throttle. This one is rotating, say 0 to, for example, 90 degree. Okay, that time the shaft also rotates. So what will happen? This moving contact. This is called as moving contact. The moving contact will move over this. So that is what called as 3. Okay. Now if I press the throttle pedal, the shaft rotates from 0 to 90 degree. The moving contact can be like this. For understanding purpose, I'm saying now if I measure this voltage, that means moving contact is here. The voltage will be 0 volts. Please see that this is minus, this is plus. So this end will be 0 volts. This end will be, for example, this is 10 volts. Here will be 10 volts. Okay. Now the moving contact comes to one end. That means when throttle is a 0 degree, the output voltage is 0. Okay. Now if I press this one anti-clockwise, if I rotate, the moving contact moves like this. Then it moves like this. As it moves, when it comes to other end, this 90 degree, the moving contact comes here. So it will have 10 volts. Correct? The moving contact can be here, or it can be here, or it can be here, depending upon the shaft position. So when it moves over this, from 0 to 10 volts will be the output voltage. This is the output voltage. It will vary from 0 to 10 volt when the shaft rotates 0 to 90 degree. So this is how your TPS sensor works in engine control. Correct? So this is what part it is used to measure the angle. 0 to 90 degrees measured, which represents 0 to 10 volts. Okay, this is one of the simplest sensor, because you know the TPS costs around 500 rupees in bulk. If you buy individual, maybe this one. And this is simple resistive type sensor. Correct? That's what I told you. To understand you, what I did, we applied a constant voltage, for example, 10 volts from your battery or 5 volts. Generally, they apply 5 volts. So when this is moving contact, moves up and down when this shaft is rotated. Okay, this is connected to your throttle cable, throttle shaft. So it rotates. So that means this contact can be here, this can be here, this can be here, this can go here. When there is here, it shows 0 to 270 degree. Correct? So the angle, you can see that the angle is 0 to 270. If I am supply with 5 volts and this is 5, I am supplying 5 volts, the output voltage, the output will vary 0 to 5 volts. So what is this one? If shaft rotated by 1 degree, what is voltage? That is 5 volts divided by 270 is called as angle resolution. Note down. It is called angle resolution. So 5 volts can be written as 5000 millivolts divided by 270. Correct? 5000 divided by 27. 500 divided by 27. 50. I can take this is 1.
So approximately 18. You
They only shared mail for all the.
Yeah, 18 millivolts per degree angle. If throttle position sensor moves 1 degree, it will give 18 millivolts. So you can see that this is throttle angle 0 to 270 degree. It is vary from 0 to 5 volts. So it's a linear output. This is how the throttle position sensor works. So if I ask, find out if your TPS sensor varies, here I said 270 degree. Instead I said 180 degree, 0 to 180 degree. Apply to this 10 volts, correct? 0 to 10 volts. Find the angle resolution TPS sensor. What you will do? 10 divided by 180 will be the resolution to compute. Okay. The next type of sensor. Okay, time up. I think I will stop here. We will see in the next class. Continue because the 2 sensor we'll see. After that, we'll go to amplifiers. We have to start next chapter. We'll talk about 2 type of angle sensor next class. The other teacher will be waiting. Anyhow, tomorrow no class based on the your class representative request. You have to thank all of you. You already last week it's told we are all going home. Enjoy your Diwali. Okay.
Thank you, sir.
Sir, ಇನಿಯ ದೀಪಾವಳಿ 40 sir.
Hey, this too much. Hey, Arnasam, இவர் என்ன பண்றது நம்மளை விட முந்திடுறாரு ஒவ்வொரு தரமும் நம்ம சொல்லலான்னு பார்த்தா முந்திடுறாருங்க. Thank you very much. Literally, you are talking very nicely. Correct?
Very nice.
Highly appreciate.
Sir,
No.
ಇನಿಯ ದೀಪಾವಳಿ 40 sir.
Exactly, correct. No, even Tamilian doesn't talk like that. They say Diwali greetings. What do they say? Diwali greetings. All English. You are talking Deepavali, Iniya Deepavali Nalvaltu. Nobody has told it.
Nice,
Today,
sir.
10 to 20 students, some faculty, everybody will happy Deepavali. Even Tamilians, local Tamil professors are students. You have to appreciate it. You will get some bonus work, don't worry. Okay, for everybody, happy Diwali, take care. We'll meet on Monday. Okay?
Thank you,
sir.
Thank
Thank you, sir.
Thank you.
Careful.
Happy Diwali.
While,
Happy
yeah,
Diwali,
same
sir.
thing. Main thing, while busting cracker, careful. While driving also, be careful. Lot of traffic everywhere. Correct? I saw in the afternoon, so I saw people start going from Chennai. I went to Adayar. In front of IIT, a lot of traffic. I asked, sir, everybody going on today itself. Some people are going today itself.
Nice, sir.
Okay.
Thank you,
Anyhow,
sir.
see you
Sir.
on Monday. Good luck.
You firecrackers?
I almost 50 years before. 50 years before. After that, no. But my kids were doing, my son and daughter, up to 5th standard. We are staying in IIT, no? IIT, we have a lot of deer, monkeys, animals are there. There is one association which wanted to educate kids. Correct? There's they always come and send mails, all those things to kids, school kids. Don't bust cracker, where the animals will go, where birds will go, they will be get scared. You are polluting, don't do. So both my son and daughter, when they are 5th and 3rd standard, they said we won't bird cracker. My teachers told these they come and advice. They said, give me that money, we'll put it in our saving account. So they collect the money, whatever it is. So I buy 2,000, 3,000, they divide and put it in the savings account. That's what they're doing for last 10 to 15 years. So
Oh,
no
great.
crackers.
Great, sir. Great, sir. Even we also avoid. Great, sir.
Okay. No, but I did not do anything because I have to thank, you have to thank the teachers of the school and that welfare association who came and told the students in prayer meeting something, don't bust something. So they immediately stopped. We won't bust. We don't want to scare monkeys, deers, all those things. They stopped it. Then they said pollution also will be stopped. So then I was also happy that okay. But they said, give me my share, buying a cracker money. You cannot escape from that. They collect money, put it in the savings account.
That is required, sir.
No, one thing is they are cultivating savings that this one, no, from young age. That is also important. No, that is also nice of it. Okay. Anyhow, enjoy your Diwali with your family, friends safely. Traveling, also do safe traveling. We'll see you on Monday. Thank you very much. Bye.
Thank you, sir.
Thank you so much.
Yeah.
Bye bye, sir.
Bye bye.
Happy
Happy Diwali, sir.
Happy Diwali. Give your attendance before going. That is very important for me.
Definitely, sir.
Yes. Good luck.